So if you want to capture high resolution shots of the solar surface, then get yourself a solar telescope and join us as we're going to capture a time lapse of a solar prominence. My name is Mark Radici and welcome to the Refreshing Views Observatory. So when I started observing too many years ago now, the idea of solar observing was absolutely terrifying, and quite rightly so. Now the beauty of these instruments is that they have an energy rejection filter in, and that rejects away all but a tiny fraction of the sunlight, of the energy that's coming through, making them safe to use. They also have an ettalon, and that only passes through the wavelengths of light from the sun's chromosphere, and that's where all the action is, that's where the flares and the prominences are. So with these instruments we can observe the sun safely and see where all the action is. So I've been practicing my workflow over the last few months. Now I've been posting them on the social medias, and I've had a comment from Stephen. Stephen is a flat earther, and he says this video is full of so what I'm going to do is talk you through my workflow, and then maybe you and maybe Stephen can understand how we take these pictures. So this is a Lunt 60mm. It's a few years old now, and it has a solar finder on it because you don't want to look through a finder scope. And I also put my laptop in a plastic tub. It also has a blanket over it, and that's just so that I can see the screen in the bright sunshine. So the telescope has a tuning knob, so I can tune the waveband, the ettalon that comes through. And what I found my favourite position that seems to bring out all the sort of prominences, the solar flares, and I just leave it in that position. So that never changes. So that's the camera. This is a Saturn M camera. It's a mono player one camera, and the good thing about this one, it's got a massive chip, so loads of pixels, so I can record the whole solar image in one shot. I don't have to make a mosaic like I used to with my old camera. And it's also a mono camera. All the light that comes through the solar scope is really in the red wavelengths. So if you've got a colour camera, your green and your blue pixels aren't really doing anything, so you're about a quarter or whatever it is of the sensitivity. So having a mono camera for solar shots is really important. And the other thing I like about this is it has a tilt adapter. You can probably see it better on this side there, so you can adjust the tilt only by a couple of degrees or something like that, just to introduce a little bit of a wedge angle, and that gets rid of those ring effects. So before we start our time lapse, I'm just going to talk you through a few features in FireCapture. Now FireCapture is one I like to use to control the astronomy camera. It's a piece of freeware and it's available for download. I'm running version 2.7, it's still in the beta mode, but that's what controls the Player One camera. And the reason why we're going to use FireCapture is, of course, when you look at these high resolution pictures of the sun, you can see the atmospheric turbulence, and what we're going to do is record loads of sharp images. We'll then reject the blurry ones, we'll stack the good sharp frames one on top of the other, and then we'll process that to bring out all the fine details. Now there's a few features I suggest we do before we start looking at the actual time-lapse itself. The first thing is to go into the settings. Now if I go to capture settings, I record all my video imagery in a folder on my D drive. That's the new images, and I include the object. So for example here, if I just move that out of the way, I'm recording the sun in H alpha, and that then appears there in the file name. So I've got sun in H alpha, and I record year, month, date in the folder, in the file name. So I beg your pardon, in the folder name. And that means that then they're all numbered in date order, in consecutive order. So every day I come out, or every clear day, come out, make my observations, they all appear in numerical order. I also click on use universal time, and that means I don't have to worry about daylight saving time, summertime. It's always recording that in universal time. And then when I'm doing my planetary imaging, obviously that's not so important for the sun, I do my WinDupos file naming. So when we come to derotate Jupiter or Saturn or Mars, it's already got the names in and the times to do that automatically. The other feature I use a lot is gamma. Now gamma, you don't record with gamma, but if I click that on, I've set it to 80, and what that does is it brightens the image, makes all the faint prominences, so it can be quite hard to see, makes them easier to see. So when you're out in the bright sunshine, you can then see the prominences and then zoom into what you want to do. Always remember to turn it off though. Don't capture with gamma. All that data, all the prominences are going to be in the data, and we can bring that out in processing afterwards.
The other useful feature, if you look at this, I'm recording 3000 by 3000 pixels, and the sun without a Barlow will be quite small in the middle of the field of view, so we don't need to record all that. There's a lot of wasted space coming down the USB. Your frame rate is going to be reduced, and of course the file sizes are going to be much bigger. So what we can do is choose something in here that's maybe a bit more appropriate, and then fit that on the screen. That button there is to fit it on the screen. So it increases your data rate down the USB cable so you can record a faster frame rate, and of course it saves space on your hard drive as well.
Oh wow. A few little prominences. Don't record with gamma, leave that off. So what I'm going to do now is I'm going to put the Barlow in, and we're going to capture some high resolution shots of the solar surface. What I'm going to use is the time-lapse function in FireCapture, so that we can then record 30 seconds of video, 30-second gap, and I'll just record that for about an hour. Just chill out, I'm going to make a pot of tea, and then we'll just look at the solar surface. We'll then put those frames together, we'll process each one in turn, we'll put them together, align them up, and it's all done auto-magically. So it's a nice Barlow lens. This is a 2.5 Teleview powermate, 2.5 times Teleview powermate, really nice. And with the pixel sizes on the camera, and with this 60mm f5, it's the old style Lunt solar telescope. It's just the right resolution. Put you in there, so that's the camera, and it's got the IR cut filter on as well. Line that up. If I line that up with the direction of the telescope, then my up, down, left, right on the hand controller are still in the right direction, and I just drape the cable over one of the little knobs on the mount. That just gives it a little bit of strain relief on the back. Don't knock your tea over. Here we come. Oh, look at that. Right, then we'll use this little chap over here, and I'm going to record 30 seconds of video with a delay of 30 seconds. So every 30 seconds I'm going to record 150 frames per second. So start the auto run. So I now just sit here capturing 30 seconds of video with a 30-second delay at 100 and something frames per second. And I just sit here drinking my tea, and I'm just going to listen to the birdsong. So that's the solar prominence we're capturing, and you can see the evolution just in the sort of 20-30 minutes I've been out here. Absolutely amazing. So here are all our video captures. So every minute we recorded 30 seconds of video. What I'm going to do now is load all of these into a program called Autostakkert. Now again, Autostakkert is a piece of freeware, and what it's going to do is going to sort through each of those videos, pick the sharpest frames, and then stack. And then we'll go all the way down to the end. So 10, 12. So I'm going to open that. So you have to check on this screen here that it's on surface. You don't want planet, so a planet needs to have a black ring all the way around it, black sky all the way around it. So I always leave it expand or crop it later. Check your noise robustness. So I leave mine on 5, which is the normal number. You can boost this up if you've got a very noisy image, a low signal to noise ratio, but 5 for our settings will work fine. So the other thing to do is you've got this green square just here, and you need to put this on somewhere with a good contrast, a good level of contrast. So I'm just going to move the green square up to here. We've got this white patch, this black stripe, and that means it's got something to anchor, to stabilise the images against. Each frame is going to be linked to that point. Hit analyse.
So the software is going to have a think. It's going to sort through 3,446 frames of that video file. So this is the sharpest frame, frame number 3,207. So this is the sharpest frame of 3,446. And if you slide this along, you'll see the frames are all nicely linked together. Obviously my tracking wanders around. I'm just moving that bar along, and as we get down towards the end, there's some pretty low quality. So that's where the atmosphere was blurry. That's where there was no fine details. The seeing had ruined the appearance of the frames. The other thing I found very useful is using the quality graph. So what it's done, it's recorded over time the 3,446 frames. So you can see scene's good, scene's bad, scene's good. You've got that sort of quite sharp sawtooth. And then the green line is that sorted into quality order. So you can see there we've got loads of very poor frames and some very good, and there's a massive drop. So let's move over to there. So if I slide this along again, you can see that line moving along. So it thinks that's where all our good frames are. I think it drops off right at the end. So you can see here we're getting pretty poor quality. So let's have a look around here before it starts to drop off. So that is number 621. So based on my settings with my camera under my scene conditions, I find 500 frames is about the right number to sort. Sorry, the right number to stack. So I leave it as a TIFF, so we get a nice 16-bit TIFF uncompressed image. I don't use any drizzle. There's no need to use drizzle if we've got the Barlow in. So what Autostakkert can do is going to break this image down into a whole load of squares. It's going to look for the sharpest point in each square and then recombine them and stack them all together. So what we're going to do is we're going to set about 160. We are going to make sure we're on multi-scale, and I'm going to hit place APs in grid. And I've deliberately left the brightness at around about 15, and the purpose of that is that I don't want to stack all this black stuff. That's just a waste of space. So we've got 95 alignment points. We could probably go a bit better actually. Let's go for 120. It's a bit subjective this. If you have loads of really tiny little alignment points, software takes forever and you can get this mosaic-y effect. So it's a bit subjective. 191 is probably right. I mean, if we did 24, yeah, you can see that's a ridiculous amount of points to do. You know, 6,102 frames are all going to be, sorry, each frame's going to be broken down into 6,102 squares and recombined. So about 120 looks about right, but that's my subjective assessment. But make sure you've selected multi-scale. Place APs in grid, and I've clicked on replace, so I already had replace in there. Otherwise I'll stack them one on top of the other. Our prominence is in there. We saw it when we were doing the really small pixels in there, but it's just hidden behind. It's quite low brightness, but we'll bring that out afterwards. And it's then a case of hitting stack, and then we'll go and make a paucity, because this is going to take forever. So if you've seen any of the lunar and planetary imaging stuff, I use Registacks to do the wavelets. That brings out all the sharp images. There's a better program I find for the solar imaging, and again, this is all freeware, all free stuff. And it's called ImPPG. So what I'll do then, I'm going to load the first image, 25th of June, and Autostakkert has put them all in an AS500. So it's Autostakkert frames 500. So we've got a stack of every single picture we took. So what we'll do, we'll open up the first one. Now there's two parts to ImPPG. You've got the sort of sharpening, the Lucy Richardson deconvolution. So, and then you've got this tone curve down here. Now again, for my settings, I find if we put this up a smidge, let's try 1.5. Oh, the other thing you've got to do as well is select and process the whole image. And then you get to see the whole thing rather than just that little square in the middle. So that's a little bit sharper. You can see there's some details being brought out. So let's bump that up again. Let's go to like something silly like 2.5. And you can see that that's become over processed. That doesn't look so good. That's quite sort of grainy, nasty sort of texture. So I find with my settings about 1.9, but you'll have to play for that, whatever works for you. So again, we've got a nice sharp image, but we don't have that blocky, horrible sort of texture.
And as you can see, the prominence is there. I can just see it looking there if I squint carefully, but it's not very obvious. And you have the tone curve. And if the tone curve doesn't appear, you press this button up here, show tone curve editor, and show processing controls. Now, what happens is you can boost this up and down this line, and it makes things appear and disappear in different parts of the spectrum here. So this is black down here. This is the blackest of the black of the pixels, and this is the brightest, whitest of the pixels, and everything in between. So by moving this up and down, we can make different parts of the image appear brighter and darker. So I find if I reset that, if I bring this up, that brings out the prominences, but you've then got to drop it straight back down again, otherwise you over process the surface of the chromosphere. It's pretty good, so that's not looking too bad. So that's what I found works best for, again, for my camera with my settings, with my telescope. So when you've got a tone curve that you like, that's brought out all that faint details without burning anything out, you've got a sigma that you like, the next thing to do is just save your settings, save processing settings. And then I've saved mine. I did mine on the 22nd of June, 533 surface and prom, and that's the settings I like to use now. So I won't save over it. And you'll find this really useful because when we've got a whole load of images to process, that'll save you a lot of time. Now if we have to manually go in and process each one and then save it and open it and process it and save it and open and process it, we're going to be here all day. So what I do is you go File, Batch Processing. We'll add our files. 25th of June, ASI 500, so we want that one. All the way down to the end, not the whole disk. Open. We will then, I've saved this as a setting, so I'm going to save that surface, open that, and then the output file, browse. And I'll call this YouTube tutorial, if I can spell tutorial right. YouTube tutorial select folder. And then hit, and the output is, I can leave as 16-bit, so we've got all the fine details. There's no compression. So processing is completed. Let's OK that. Now, so tracking wasn't perfect. The image is naturally going to have wandered around slightly. They'll all be roughly in the right place, but they won't quite line up to it. So the next thing we're going to do is go Tools, Align Image Sequence. And it's a bit like we did before. We're going to add files all the way down to the end. We'll go Open. I again like to pad to the expanding box. You can crop if you're pretty confident, but I tend to find it wanders off a little bit, so I pad to the bounding box, and let's browse. New folder. Let's call that Align. Select folder and then start processing. It's going to have a think. It's got frame 1, so it's moved it by 4 pixels, 8 pixels, 17, 11. So as long as it's doing this, as long as the numbers aren't jumping around too much, it's not looking too bad. So it's now saving all the images. So if we go to Windows Explorer, some of them have worked. Look, as I click through those. Okay, so the next thing we'll do then, having done all that, we'll open up Photoshop. So let's open up YouTube tutorial. Now if you remember, my camera is a black and white camera, so there's no colour data at all. ImPPG also processes in black and white, so if you want to then add colour back in and make it look a more natural sun colour, image mode, RGB colour, so we turn it into a colour. It's still got no colour data, but at least the Photoshop now thinks of it as a colour file. Make that a bit bigger. And then we'll go Image, Adjustments, Levels, go to the red, make that 1.6, go to the green, make that 0.6, and we'll go to the blue,
make that 0.2, and there we have a colour image of the sun. Now I've saved that as a action in Windows, so I can literally do that, and that's my solar black and white colour. There's the original one, solar black and white colour. I recorded this as a macro, as an action, and there it is, appears in colour. So what we can do then is then go File, Automate, Batch. Got solar black and white colour saved as our action. We'll select a folder, we'll choose our folder, 25th of June, YouTube tutorial, select folder, and then we'll hit OK. So if I then go into YouTube tutorial, it's going to change each and every picture into an orange one. I think I may have done that twice, so I might have to undo that one. I'll come back and do that one later. Right, so that looks like we've processed all the images. We've got nice colour, solar looking image. So the next thing we're going to do is go File, Scripts, Load Files into Stats. So it's going to open up all those pictures but into one, it's going to load up all those frames but in one picture. They'll all be different layers, one on top of the other. So we'll go Browse, YouTube tutorial. I'm going to ignore the first one, all of those, and we'll go OK. Click Attempt to automatically align source images. OK, that. So in here then we have 77 frames. They've all been automatically aligned in Photoshop. It's actually done a far better job than ImPPG did. Window, timeline. So Photoshop, you can also make videos. Down here, create frame animation. So click on create frame animation. There we are. So the first image appears. And then come into here, and then we're going to go make frames from layers. And it then puts all 77 or 76 if we just deleted one into position. Now I like, and it's just the way I am, 90 degrees clockwise, more sort of natural horizontal horizon sort of view. Zoom out a little bit, and what I'm going to do is then crop away all this empty space as the image jumps around. So let's do something like that. Hope that's enough of a crop. So it's rotated every frame, it's then cropped every frame, and it's aligned every frame, and it's coloured every frame. So Photoshop's actually quite a powerful tool for doing this. What I'm going to do then is select the first frame, select the last frame, and I'm going to right click and call it 0.1 seconds. So it's doing 10 frames a second, so it's about 7 seconds long, this time lapse. I'll make it fit on the screen by pressing Ctrl-0, and then I'm going to hit play. Get that a bit bigger. So we can see the prominence moving then, a little bit jumping around as the cloud got in the way. If you find for whatever reason Photoshop hasn't displayed the frames in the correct order, Photoshop's put them in the reverse order, then just go into the three little lines and click reverse frames. What we're going to do then, there you go, is File, Export, Render Video, and we'll call that 2023-06-25 from time-lapse 10 frames per second. And I just leave it on these default settings, make sure it's high quality. Then where we're going to put that, select folder, in the YouTube tutorial, select folder, render. And if I go to the YouTube tutorial, in there should be a prominence time lapse. So this is what I find incredible about this, is that we've got a sort of amateur telescope in a shed in a garden in southern England, and with off-the-shelf hardware, with off-the-shelf camera, and with some software, I've actually recorded a time lapse of a solar eruption, a prominence, a flare, erupting on the solar surface and capture that over time. And by far the longest bit is the actual image capture, watching the sun for an hour or two. But as you can see, it's quite a pleasant experience. You get to chill out, have a cup of tea, listen to the bird song, and then the software is the one that really does all the work. And by having all those scripts in ImPPG to do that batch processing of the bring out all the details, to then use Photoshop to align each image and to color each image, makes a video in very little time. By far the longest part is the actual image capture. As always, if you've enjoyed this video, then please do chuck us a like or a subscribe. We don't charge any money. We don't expect to have you sending money on Patreon to buy my telescopes and cameras. It's all there as a gift to the community. So if you did enjoy it, chuck us a subscribe, and I'll see you in the next video. So you can zoom in, zoom out, or fit on the screen. So you don't have to record at the full capability of the camera, and indeed if it's not filling the field of view, if it does fill the field of view, so if it's not filling the field of view, then obviously you can reduce your region of interest. And then click attempt to automatically align image, blah, blah, blah.